Hello everyone. So today in this video I'll be discussing two problems, one from JEE Advanced 2019, another from Pathfinder, that is from Challenge Your Understanding. Well, both questions have a small concept common in both, that is the concept of 1D gas. We know that we have dealt with kinetic energies and the models, different kinds of models of gases, but in three-dimensional. Today we'll be discussing about that only, but in 1D problem, 1D method. Okay, so I'll be presenting you two methods to solve this. The advanced problem, that is, first is the mechanics method, and second will be the thermodynamics method. Without further delay, let's get started. The question says that you have a small particle of mass m moving inside a heavy, hollow, and a straight tube. Okay, and it undergoes elastic collision at two ends. The tube has no friction and it's closed at one end by a flat surface, while the other end is fitted to a heavy movable piston as shown. When the distance of the piston from the closed end is L0, the particle speed is V is equals to V naught. The piston is moved inward by a very low speed, that's such that V is much less than dl by L into V naught, where dl is the infinitesimal displacement of the piston. Now we have to tell the correct options. First option says that the rate at which particle strikes the piston is v by L. Second is after each collision with the piston, the particle speed increases by 2v. Third is the piston moves inward by dl. The speed increases by 2v into dl by L. Now fourth option says that the particle's kinetic energy increases by a factor of v naught, factor of 4, when the piston is moved inward from L naught to 1 by 2 L naught. Pause the video, give it a try. If you want to give the try to the other problem, you can look at that. This is the Pathfinder problem, which I'll be discussing it in this video. So just read it once. We'll be getting started. Hope you gave a try to these problems. So let's get started. So the answer to this problem is B and D. Now how can we explain this? So what will happen basically, suppose this is my piston. Let me keep it down. Suppose this is my piston, I'm drawing it. So this is my tube and this is my piston. This is the heavy piston and here is my mass. Now you have to tell me the rate of the collision with the piston. What will happen was that first the mass will go from here, then it will strike the piston here. So you can see that when it has moved a distance of 2L, it strikes the piston once. Okay, you can also take this interval from here to here, then it strikes the piston and again comes here. So in one complete motion, it covers a distance of 2L and strikes the piston once. So the time required would be 2L by V, and we know frequency is equals to inverse of time period, which will be V by 2L. So instead V by L, it must be V by 2L. So the first answer is of course incorrect. And let us discuss the second option. Second option says that after each collision of the piston, the particle speed increases by V. Yeah, of course, because piston velocity is capital V much less than dl by L into V naught. So it means that it's going very slowly, and we know that if a very heavy mass, suppose a truck is coming and it hits a fly which is moving with velocity v, and the truck is coming with velocity v dash, then the b again starts to move with velocity v plus 2v dash, because the truck's velocity will almost remain unchanged and the b's velocity will become infinite, means very large. Okay, it will increase but by 2v dash. So the after each collision the particle speed increases by 2v, of course correct. Third option says that if the piston moves inward by dl, then the particle speed increases by 2v dl by L. So coming to option C. Well, for option C we need to do some manipulation. So what will be the manipulation? That in that period when it moves by dl, then the time passed will be dt will be equal to dl by capital V. So this is the time for which the piston moves. Now how many collisions takes place in this time? The number of collisions is dt by capital T, which will come out to be dl by v into, well, here it will be v naught, let it be v dash, because v dash is the velocity of the particle. Just a minute, v dash into 12. So this is the number of collisions. Now by how much factor will it increase? It will increase by a factor of 2v. So it will be 2v, and capital V cancel. Let me for now assume the velocity of the ball to be u instead of v dash. U means I'm just defining a random parameter, that if the velocity of ball has increased to u, then it's now undergoing that same process. So I can say that the change in velocity du positive, because it's increasing, is equals to 2l dl by u. Just a minute. Well, I guess here's some mistake I committed. It says the piston moves inward by dl. The particle speed increases by 2v dl by l. Now, how much time will be elapsed? Time elapsed will be dl by capital V, right? Now, how many times the collision occurred? That is equal to division by time period, which will be 2l by u. This is the number of collision occurred. Yeah, it will be 2l by u. 2l, and here will be an u. So 2 gets cancelled. You will get u by l, u dl by l. So I can say du by u is equals to dl by l, and see here it will be a minus dl because the length is decreasing. So I can say that du by u plus dl by l is equals to 0. Now it's saying, option C is saying that if the piston moves inward by dl. Now in this case I have to take positive dl because it's already saying that it moved inward by dl. It moved inward by dl means it has moved outward by minus dl, right? So in this case minus dl is equals to plus capital dl. So it must be only v dl by l instead of 2v dl by l. So that is why option C is wrong. Coming to option D, it says that kinetic energy increases by a factor of 4 when the piston moves inward from L0 to L0 by 2. So from this differential equation, I can say that UL is equals to constant. Now length halves, so U increases by a factor of 2 times. Okay. I can say that kinetic energy equals to half mu square. So kinetic energy increases by 4 times. And that's the answer. So option D is correct. Hence the answer to this question will be B and D. Now you might be wondering what is the relation of this with thermodynamics. Well, I'm not going into detailed derivation of the equations and doing all the KTG, all those stuff, but I'm just giving you a small analogy. You observe that UL, what is U? U is the velocity, L is the length. Now what is the concept behind it is that in this case the degree of freedom, that is small f would be 1 because it's a 1D motion. That is why degree of freedom would be 1. In case of 3D motion it would be 2, but in this case it would be 3. But in this case it is only constant to move in 1D path. That is why degree of freedom would be 1. Now gamma would be f plus 2 by f, which will come out to be 3. So I can say that whether this process would be adiabatic, isothermal, or what. Now consider an adiabatic process. What is the key concept behind adiabatic process? That some work will be done, and though that work will be transferred in form of internal energy. Now what is internal energy? Kinetic energy. Now what is isothermal process? Isothermal process says that the internal energy will remain constant because some other means of energy, that is called the heat energy, is being exposed out of the gas through heat. That is, heat is given out from the gas because some work is done on the gas. So you can say that the motion of the ball inside the piston, inside the tube with the piston, is basically an adiabatic process. So it's an adiabatic process. I can say P v to the power 3 is equals to constant, and that's the very important step in this problem. I can say P to be P is equals to T by V. So I can say T V square is equals to constant. Now observe that we know that energy is written as half kBt for each degree of freedom. So I can say energy times velocity volume square is equals to constant. Now here the areal dimension is constant, but it's a 1D motion. So I'll just write it in form area times length square. Area is a constant, just ignore it. So energy times length square will be constant. Now length halves, energy becomes 4 times. That's the important concept which is involved in this question. That is, you can consider the motion of the mass inside the tube as a quasi-static and an adiabatic process. This is a very important observation in this question, right? Hope you get it. And this way we can get the option D, and part B is just a subpart of center of mass chapter. Hope you enjoyed it. Now let us go to the pathfinder problem.